everyone. My name is Alex Rössler, and my company is Machine Koder, as already mentioned. And I create user interfaces for industrial machines, be it an industrial robot, be it a machine tool, or some other industrial machine. And today I'm going to talk about my experiences from working with Qt and Python on a real-life project. So not like something like a example Hello World application, but something like a little bit bigger, and how it actually came to all this. So I'm also going to talk a little bit about how the project is built up, like the project structure, a little bit about the architecture, the workflow when working with Python and Qt, some issues that you may face when you are working with Qt and Python, and last but not least, my conclusion on whether you should use Python or not. So first of all, I actually started to work with Qt more than 10 years ago, and actually transitioned at this time from using Delphi. At this time, I was still on Windows, and we used Delphi at school. And actually, I switched over to Qt and C++ because I switched to Linux. And Qt was very available, was working with KDE and so on. And that's why I started with Qt and C++. So I never touched Python at this time. The first time I actually got in contact with Qt and Python, especially with PyQt at this time, when I created some user interfaces for an open source software project called Machine Kit. And the user interfaces before were like also Python based, but they used TK and some used GTK for the UIs. And I thought, well, it's time to switch to make nicer user interfaces, more modern user interfaces. And at this time, I also was trying out Python, actually. So I had the option of using C++ or Python at the time. And I tried Python, but there was one big problem here at this time. The idea was to run these user interfaces on an Android phone or Android tablet. But the problem was, well, Python is cross-platform, but it doesn't really work with, especially not with Qt on an Android phone. So at this time, I had to move to C++. And I actually had some objections also at this time, besides that it's not cross-platform capable. First of all, I thought, well, Python is cool, but not really scalable. It's nice for some scripts, maybe some small programs, some tools, whatever, but not really for a bigger application. It is slow. Well, that was my thought. Of course, everyone hears, yeah, C++ is really fast, it's compiled and everything, and Python, well. Then I had also in mind, well, it's maybe not safe because, well, it has no typing, it has no static typing and so on. It's interpreted language, usually can inject something or so. And also the thought, well, it's just only for prototyping only. But the biggest problem at this time actually was that it's not available or was not available for mobile operating systems, which was a showstopper. A couple of years later, or like 2 years ago approximately, one of my customers, which creates CNC machines for small businesses, small workshops and so on, decided, well, we extend the product palette with a new product. And this company is very focused on creating easy-to-use user interfaces. So their idea here is actually that the operators that use this machine are usually not always like trained engineers, like trained machinists, but people that use the first time a CNC machine. So really the key here is that the user interface is easy to use and has a lot of functionality built in, which a normal CNC machine, if you ever seen a CNC machine from, I don't know, Siemens or so, you probably see that's really complicated, a lot of buttons, and if you never have learned it, you probably don't know how to use it. And here the idea was make it really user-friendly. And so this company decided they might also make it possible to use robots, because like the next step when building or creating products is actually automation. And currently that's not really accessible from a lot of companies because it's usually hard to program a robot, at least for people that never programmed a robot before. And the currently used user interface is actually based on Python with GTK, but we were deciding to use ROS, the robot operating system, as a basis for controlling the robot. ROS is pretty cool. And there's also this ROS industrial incentive and so on, which is really targeting industrial applications. And in the ROS community, there is this idea of using a programming language for what it's made for. So they use ROS. In ROS, they use Python, they use C++. They use basically both. And some tools are written in C++, some are written in Python. And so you already have both languages in there. And there's also a tool or like a graphical tool called Arvis, which has a very nice graphical interface for basically controlling the robot and moving around the robot arm, in this case, for example. And so the idea was, well, in the future, what's going to happen? GTK2 is deprecated anyway, so we won't use GTK2 anymore. GTK3 is, well, no, not really nice. And in ROS, actually, all the user interfaces are Qt-based. So the idea was, well, maybe you can reuse stuff. And at first, I thought, just use C++ because C++ is well known, it works, and so on. But since in a company like Python is very widely used, we decided to go and try out if we can build it with Python first. And in case it doesn't work, we just move over to C++. And that's what we did. So we tried it, and we ended up creating a user interface, which looks very similar to the existing user interface, just for a robot in this case. And the nice thing is, actually, since we decided to use ROS and also Python, we could actually reuse a lot of parts of functionality implemented in ROS. And also, for example, in this case, the 3D preview. Out of Arvis is actually written in C++. So that's actually a component that's written in C++ and with a third-party rendering engine, so it's not Qt3D, embedded into a QML application. It's just one part. There's also a nice side feature, actually, is in the robot, like when you want to program a robot, especially industrial robot, there is no common standard, actually, for writing the robot program. Every vendor has its own language. And so we actually would have ended up inventing our own language anyway. So there was no possibility to reuse anything. I mean, there's G-code for CNC machines, but it's static. It's not really nice to program and so on. So we thought, well, Python is already well known. Why not reuse Python? And the nice thing about that is we got the possibility here as well to use the Python abstract syntax tree to actually parse Python programs and make it visually programmable, so to speak. There's this like a graphical user interface for programming Python programs. Another feature we could reuse were the tooltips that were already available in the old UI, and we could reuse, in this case, this was implemented in Python. So we could reuse the code that was what generates the tooltips, basically. And that's possible because we use QML. QML is very easy to use, and on the other hand, Python, because we can reuse existing code. So now I want to tell you a little bit about the project structure. And here we go. And the one thing you face when you're building a bigger application is that, well, a small application in QML is pretty straightforward. It's probably one file or like 10 files or so. It's pretty easy. Like how do you build up the application? But once you build something bigger, it usually gets a big mess. It's something, especially when you're first starting out writing QML. And I first came across some references how to structure QML, so at the QtCon 2016. And a little bit later, I come across one of the reference UIs called Neptune 3. I think it's part of the automotive suite, and got a little bit inspired by that, how to structure the QML code. And so here the idea is basically that you have like your state is shared between the QML files. So sometimes in an application, you have a shared state, and I explain it a little bit later. And I call this handlers. I think in Neptune 3, this concept is called a little bit different. but just an idea how to structure it. And for example, we have this part here. This is just a file view basically, and this is a Python component that has that basically gives us the file view as we want to see it in the application. It's a model basically, file system model, and this component is actually not a handler because it can be used in this part of the UI, can be used in the dialog and so on, and it works on its own. There is no shared state anywhere. It's just used in the UI to select the file, basically. But on the other hand, we also have components like this. Like this is a digital readout. Basically shows the current position of the robot. And it's used here, it's used here. I mean, you can argue why it's twice here, but basically it's used in different parts of the UI. And we actually want to share this state between those components. And the state actually comes from ROS itself. So it does come from the backend. And we don't want to use, basically, we make it easy to use and also share the state here and easy to access and so on. And here the idea is basically that the state comes from ROS, and we have something called the state handler in here, and it's then accessed via a reference. And that's actually the only thing where you should use a reference is actually here. Everything else is really bad, but only because it's called state handler, and it's called state handler in your application. And I will get to that later. Why you should, why that's in this case a little bit better to use than a context property or a singleton. Yeah, and the other part with Python actually is pretty cool. Python is an interpreted language, QML as well. So actually you can reuse and reload the code very quickly. And I thought about like the QML components that are written in Python, similar to the ones that are written in QML. Actually, it doesn't matter when you use it from QML. It doesn't matter if they're written in QML itself or if they're written in Python. And so I structured it in a way that they're both in the same directory. I wouldn't do that for C++, of course, but for Python, it's very useful to do that. C++ components are external and just imported as modules themselves. And QML is then used for the bindings to combine the data exposed by the models written in Python and the user interface. So now, why do I actually use these references? First of all, I use live coding. It's pretty similar, maybe if you were there in the previous talk from Felgo. The idea is to reload the parts of the application and during development. So you don't have to restart your whole application when you want to see the changes that you do in the QML file. And the nice thing about Python is, since it's also interpreted language, you also can reload the Python code quite quickly, and it gives you very short feedback loops when developing your code. And I've implemented it for C++ as well. I mean, for C++, you still have to recompile the C++ components, but still it's very useful, and you can develop very quickly. And why the references? Because parts of the UI might not need it to be reloaded. For example, this, as we've seen before, the 3D preview is really heavy to reload. So you don't want to reload it every time we change a QML file. So you can place that in a part of the application that you just keep the state, and when you reload the let's say a button, like you change a button or something, then it just reloads the button, for example. In Python, actually that's one of the cool things about using Python. The Python community is huge. So there are a lot of development tools available, which are not available in C++ or a little bit different in C++. Which one I really like, which you actually can also use when you have a C++ project, is pre-commit. It basically is a framework for creating Git hooks, so it can automatically check the code, automatic formatting, and so on. There's QML format, which is a QML formatting tool, and we actually use Docker for development and deployment of the whole application. So I really can recommend you to take a look at a little bit also the tools outside of the C++ realm. And really cool about Python, actually. That's one of the biggest advantages, in my opinion, is actually testing. In C++, writing a test is actually it's not hard, but it's a lot of work to create a new class. You're going to create a new test function, and you have to recompile, have to restart the test, and so on. In Python, that's just a matter of writing a single function. Especially when you use PyTest, for example, you just have a function that is executed every time you change the code, for example, and you see instantly, well, my test is red, my test is green, and I see, and I can basically, it works pretty similar to live coding, just for the non-visual part of the code, so that your models or your business logic, it's the same principle. Short feedback loops you can develop very quickly. As a code editor, there's also a little bit differences between C++ and Python. Right now, there is already a support for Qt Creator, but it's not up to date with what's available with other code editors. I personally use PyCharm and CLion because it also has C++, it integrates PyCharm. You might also want to check out Visual Studio Code and so on. Yeah, it's my personal preference. Yeah. And now quickly a little bit about the issues. I'm not go too deep into each details, but when you first take a look at Python and Qt, you might write your first Hello World application. And this is the first thing you see and the first thing you write. And who knows what happens when you press Control-C when you have this application running. It's just a small window popping up. Anyone? That's what you expect, but what actually happens is nothing. Still does not work because actually the Python application is never executed until you do it. Like, of course, if the application is a little bit more complex, you may have some function in the Python code being called. And simple to work around for this Hello World application is to make a timer that does nothing as calling an empty lambda. And when the lambda is called, actually a Python application can handle the event and your program gets shut down. But this is like something you have to keep in mind. The Qt event loop and the Python event handling work in parallel, not together, so to speak. So that's something you have to keep in mind, for example. There's also, in Python, has a garbage collector, so it has its own memory management system. And Qt has this basically parent-child relationship where it cleans up the UI components. And Python does not know about that. So when you create a QML component that has some external library, for example, in this example, ROS, you register a subscriber and call a feedback callback function. And you delete this button, for example, Python does not know that your button was deleted. Your Python object still exists. QML object doesn't exist anymore. And when this callback gets called, and it will get called, you get some error messages, Q object doesn't exist or something like that. So the easy workaround solution for that is, of course, when you destroy the object, make sure that you unregister any external references. Else it will not never get to the garbage collector and you get lots of error messages. I mean, there are other problems when you're working with Python and Qt. That is QML type size, type limit, which is very annoying when you write a bigger application. There are I think 15 in PySide and 16 in PyQt. Referenced here the Qt bug numbers. In PySide, you don't have the QML register singleton type. That's also another reason why I have to use references, because the singleton would be the alternative here, and it's not possible with PySide. Pretty much a showstopper for me, but yeah. In PyQt, there are a couple of other problems, so there's no clear advantage here and there. Another smaller problem is boilerplate code is needed to create properties. You get, when you write a Qt Python class, it looks a little bit ugly compared to other Python code because you have this create the signal, have to create the property and so on. It would be nice to have a wrapper that automatically creates it. And there's this whole camel case versus snake case discussion, which I will not get into, but my recommendation, use camel case when you use the grade classes with Python and Qt. Use snake case whenever you do not. So that is PEP compliant, basically. My conclusion, basically there are good reasons to use Python. My opinion, the most important reason is you might be a lot faster to implement your application. Of course, you can argue, is it really 3 to 5 times? I mean, if you're an experienced C++ developer, you're probably more to around 1.5 to 2 times. I argue that in C++, you're also still dealing with other things like linker problems, whatever, that you don't have to deal with Python at all. So that's, it depends really on the application. But in most cases, you're, especially when you have used the Python functionality, Python modules and so on, you're a lot faster when writing Python. Then popularity, of course, popularity is mostly important when it comes to support for third-party libraries. But also from a business standpoint, if a language is more popular, probably find easier to find developers and so on. So that's a little bit of an advantage for Python. Cross-platform support, yeah, that's the biggest disadvantage of Qt and Python. Currently, on mobile platforms, you're still relying on C++. There is no option for using Qt and Python on a mobile platform. There is a deployment script for PyQt, but I didn't get it to work, so it's not really there. For quality assurance, I think C++ is a little bit better. You have static typing, it's compiled, you get the errors at compile time, and in Python, you have to really make sure to write unit tests, because when you don't, it's easy to make a mistake or basically to write bad code. But you should write unit tests anyway. So in testing, Python is a lot better, in my opinion. You don't have to recompile a code. Test functions are usually a single line or a couple of lines. Creating mocks and so on is in Python easier. So I think Python wins performance. Of course, that's still a disadvantage of Python, but a lot of third-party libraries are written in C and C++. And when you're actually working with Qt, a lot of the things you use actually are already written in C++. So you don't have as much as a disadvantage here, especially when you use Python for the things it's made for. And that's basically writing high-level programs and not like some algorithms or something like that. From the features and bug side, Qt C++, you have the Qt bugs, of course. And when you have Qt and some wrapper around Qt for Python, you have the bugs from PyQt or Qt for Python on top of it. And of course, there are fewer users at the moment. So there might be bugs that never have been reported, as I mentioned before. The QValidator thing in PyQt, probably nobody used PyQt and QML, or not a lot at least, and yeah, it was never reported. Should you use PyQt or Qt for Python? Yeah, you can argue about both, but in short, just go to my website and take a look at the whole description. It's basically a matter of like, I personally would choose Qt for Python because it's supported by the Qt company, of course, and in the long term, it's probably better supported, more users and so on. But right now, there are good reasons to use PyQt still. So it's not a simple like a simple decision. You might look into this in this article I wrote here. There are plus points on both sides. But my recommendation, use a wrapper. So there are wrappers around both libraries, like Python Qt binding or QtBy, basically abstract most things. So use property and not PyQt property or something like that. My conclusion, try Qt for Python, see if it actually fits your application, and use C++ where necessary. So it's really good to use a programming language which it's really made for, and I think C++ is a really good programming language for a lot of applications, but Python is also very good for other types of applications or use cases. And the Python community is steadily growing. And especially in other disciplines, I mean, there are a lot of scientists using it, there are a lot of data scientists, AI, and so on. So actually, there's a huge benefit for using Python in these areas. And there's a huge benefit, of course, using C++ to write algorithms, to write high-performance applications, and so on. Yeah, if you have more questions, yeah, either ask me now or go to my website. And yeah, thank you for staying still here at Qt World Summit for the last talk.
Thank you, Alex. Are there any questions right now?
You mentioned that it doesn't work on mobile devices, Qt for Python. I just want to make sure, because I was going to use machine learning for image recognition on mobile phones and use some of the Python libraries. Is it? Do I have any chances to get it to use there, or?
Okay, so well, it doesn't work out of the box. You might get it to work. I mean, Python is like the most popular Python interpreters are written actually in C. So actually, C, you can compile a C application for Android. Actually, there is some script for deploying PyQt to Android. I couldn't get it to work easily. So if you spend some time on it, you might get it to work. But there's also the other option, which is actually demoed at the Qt Python stand, where you embed the Python application inside the Qt application. So that might be another option to get it to work on mobile. But I haven't seen it used yet. So yeah.
Thank you, Alex.